Hello everyone, welcome to the post-content discussion of the LeetCode contest. Today we will be solving the first three problems of the today's LeetCode contest. Yeah, let's see the what actually the each problem has involved in. So the first problem is very super easy problem which is required a simple traversal. The second problem is slight observation and bit manipulation, and problem three is completely implementation based problem. Yeah, let's start with the problem number one here. So the problem number one is compute alternating sum. You are given an integer array nums. The alternating sum of nums is the value obtained by adding elements at even indexes and subtracting the element at odd indices. That is nums of 0 minus nums of 1 plus nums of 2 minus nums of 3. So the question is very simple that you maintain a simple result variable that can store the all the calculations, right? So when if you are standing at the even indices, you are simply adding that value to your result. So if you are standing at the odd indices, you are simply subtracting that value from the result. So after that you are simply returning the result here. So yeah, this is a very simple question. I think everyone has done this one, right? Simple traversal here. So if you can see the time complexity here, so that is a big of in time complexity because we are traversing a whole complete loop here, right? From one to n. Yeah, this is all about the first problem. We don't want to waste more time on this. And let's move to the next problem. So the next problem is that longest subsequence with non-zero bitwise XOR. So you are given an integer array nums. Return the length of the longest subsequence in nums whose bitwise XOR is non-zero. If no such subsequence exists, return 0. A subsequence is a non-empty array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So we have to find the longest subsequence that is having non-zero bitwise XOR, right? Yeah, this is one of the array we are actually given integer array nums, and this is having some positive values, right? Yeah, these are having some values from the 0 to 29, right? You can see that this is the one longest subsequence is 2 comma 3. Bitwise XOR is computed as 2 XOR 3 is equal to 1. So if you could take the longest subsequence from this array, so there could be two possibilities. You can either take this two, or either you can take this two. So you cannot take whole array because if you compute the whole array XOR, it will be resulting into 0. Let's discuss in detail. So the problem is, let's say, yeah, I will be taking the first example here, one, two, three. So before that, I just want to revise the XOR table here. So let's say there are the two inputs, and we will see the how the output behaves. So when the both out inputs are low, so output should definitely low. So when there is at least one input is high, then output is high. So this is one, right? When there is a two inputs are high, then output is low, right? This is the table for XOR table, which, so when we are getting anything like in any question, if you are finding any bits XOR or XOR and or, try to think every number has its individual bits, right? Then you will be get more idea. Yeah, let me erase it. So if you can think, so we want the result as one, right? So this is what actually we want the result. So the result should be non-zero. We don't want this state. We don't want this state, right? We only want these two states. It means that we should definitely have at least, I mean that one set bit. So we'll be generalize this idea. Let's see. In the given example, this is an array. So let's find write all the number in the binary form. So if you write the binary form like 0 0 1, this is a binary form of 1. If you write 3 0 1 0, and if you write for 3, so it would be 0, yeah, sorry, it would be 1 1, right? 1 1 1. So this is a binary representation of the all these numbers. So the basic idea is that anyhow you should definitely want a non-zero number result, right? Non-zero result here. So non-zero result. So let's write something like, let's observe something here from this idea. from this table. So let's say I'm having 1 year, I'm having 0 year, I am having 1 year. Let's see the calculations here. So 1 XOR 0, 1 XOR 0, 1, right? 1 XOR 1, 0. It means that when we are having an odd number of ones, when we are having even number of ones. So this is the first observation which we can make from the XOR table. Even number of ones, then XOR is equal to 0, right? So the result, so we don't care about the unset bit, that 0 bits, because they doesn't contribute to our result, right? So the bits which are set bits, I mean that the bit which is having on, they are only contributing to our result. That means when we are having an even number of ones, the XOR is the result, and XOR is should be is equal to 0. So our focus is to try to keep the one should be odd number of times, right? Let's take example 1 XOR 1 XOR 1 XOR 0 XOR 0. Let's calculate this result. 1 XOR 1, 0, right? If you calculate this result, we are getting 0. 0 XOR 1, 1. 1 XOR 0, 1. 1 XOR 0, 1, right? So when we are having odd number of ones, we will be having output as 1, definitely. So this is the second observation. When we are having odd number of ones, then we will be having XOR as 1, right? So XOR is equal to 1. So this is what we actually want, right? We if you if we So our main focus is that we just want to increase our subsequence length, try to keep it as much as maximum possible maximum. Yeah. So we done with the we just observe the how each individual bits are behaving. So if you can think that in the question we are given that, so each integer can be represented from the it could be in the range between the 0 to 1 in 9, right? So this is the what the range of the integer that present in the array. So if you could think that the worst like worst case, that is 1 in 9, so that could be represented as in 30 bits, right? So this is what we should definitely know about this when we are, if you have basic idea about the bit manipulation. So the largest number, the 1 in 9 number, should be represented with 30 bits. That means, so if you could think every number has is individual bits. Let's see, let's I just want to realize it. Yeah, this would be helpful for us. Let me write it out. Yeah. So we just retain the all these numbers and their binary representation, right? So this is a 0th bit, this is a 1 bit, this is second bit, right? So what we can do is, in the worst case, we will be having, if the number is 1 in 9, so this would be something look like 31 bits. So this number we will be having 30, yeah, 30 bits. That means we will be traversing for each individual bits. So what we can do is that if you are standing at 0th bit, I just want to find key that, do I have any, so there could be only two possibilities. Either you will find odd number of ones, right? Either you could find even number of ones, right? If you are found the odd number of ones, that means you can take complete array. In this case, you can see that we will be having odd number of ones or even number of ones. That means you will be the resultant bit should be 0 here. Let me erase it out, right? So if you take all these things, and in this case you can see this is same, you will get 0, you will get if you take complete thing here, so you will get 1 here, right? So this is how you can observe the things here. Yeah. um so when the basic idea is that when you are having an odd number of ones, right? So when you are having even number of ones, the answer should be n minus 1, because we just want to remove this number, because we don't want the result should be 0, right? So if you remove this one, the result should be 1 here. If you remove this one, right, you can either remove any of the bit which is contributing here, So if you can remove this one, or in the future you can remove the bit which is contributing. So we don't want to focus on this because this is not contributing to our result. So when you are going for the second bit, you could find same thing here, right? Again you found same thing. That means you should having even number of ones in this first bit. First bit, right? So the answer should be again n minus 1. So at the last you found that there is an odd number of ones, right? So this is how you can calculate the answer here. Yeah. um yeah, these are basic observation we can do from this one. Yeah, let's take some other example from the question here. 2 3 1 2 3 4, right? Yeah, I just want to take some other example. Yeah, only take that one only. So the example is 2 3 4. If you take the um 2 here, represent all these thing in the binary representation, you would find 0 1 0 triple 1 1 double 0, right? So from this example you can see that we'll be having odd number of ones. So if you found odd number of ones, we'll definitely having like um so we can definitely go that say that the answer should be n, right? So in this case you can definitely find this is an 1. That means our complete result is non-zero. If you can do complete XOR, that is non-zero, because we don't want to care all these bits, because if you found in there is one bit that should be contributing to our answer with non-zero, then we will take n. So if you found even number of ones, then you should definitely remove any of this, right? So you don't want to make it as 0. So if you want non-zero, you should definitely remove any of the things. So in the next case, if you the 0th bit, the first bit, second bit, so in the next bit I will be taking the answer should be n minus 1. So I will be taking max of all these cases. So in the next case again you found that this the answer is n minus 1. So the maximum is n, right? So the basic idea is, if any bit, if any position of the bit, so I will be having 31 bit from 0 to n minus 1. What I can do is that in the worst case the number is 1 in 9 can be represented in 30 bits. So what I can do is that I will be traversing all the bits. So this is how, yeah, sorry, I think it should not be like this. Yeah, 30 bits. So for each bit I will be check for all the, I will be traversing all the numbers, right? um I just want to keep I will be traversing all the numbers. J is less than n, j plus plus. I just want to check that the present the position of the bit, ith bit is set or not on the particular number and all the numbers. So I will maintain count is equal to 0 here. So how we can check the number is having the ith bit is set or not? So the idea is very simple here. So let's say you can represent 0 as 10, right? So what I can do is that I can do 1 left shift I. If my 0th bit, initially I is equal to 0, so we don't want, we are having 0 here. So when I is equal to 1, I would be find that 1 left shift 1, that could be 102, right? That means you are simply doing 1 into 2 power 1. This is what actually you are doing here, right? So this is how we can find. Let me do it clearly here. So I think it doesn't clear. Yeah. Let's say if I want to find the, let's take 3, right? Yeah, sorry, take 4. The binary representation is 100. So how the 0th bit, first bit, second bit? Yeah, let's start. So we'll do bitwise and between this number 4, and we'll do this one. So 1 left shift I. This means that we will be, yeah, let me write here. So initially the I is equal to 0 here, right? So when I is equal to 0, you would be having like 4, and this AND operation is completely focusing on the bit, all individual bits. That's not in logical AND here. it's bitwise assigned, right? One left shift 0 means only it is in 0th bit. It means this is checking for these bits. So it is not set in this 4. When I is equal to 1 here, so 4 and 1 left shift 1. So yeah, basic, if you can expand this one, it's this should be look like something 1 into 2 power 0. This is 1, right? This is 1 into 2 power 1, it is 2. So it could be giving yeah, this is not set, this is giving 0 here. In the next case, if you can see that when I is equal to 2, 4 and 1 left shift 2, so you could find set right here. It means the one left shift 2 means I am shifted the 2 bits to the left side. That means 1 into 2 power 2. That is 1 into 4. So you got 4 here. It means that the second bit, the bit I the second bit, this is the position of the bit that is set in the 4, and this is how we can check this bit is set or not. Yeah, for each all the numbers I will be going for the each ith bit for in each number. So if nums of j and 1 left shift I, if it isn't set, so I will be simply counting the set bits here, right? So so this is the pseudo code how. So we'll see the what condition again required to. So we'll be, yeah, this is a simple traversal. So that could be count the number of set bits in the ith position, right? Let's see the code once. You can see initially I will be traversing all the 30 bits. In the worst case, I will be taking in the worst case. For each ith bit I will be checking the number of set bits in the ith position, right? So these loops will be going for all the numbers in the nums and checking for the ith bit only. You can see here, this is how we can check the set bit is present, is the present bit is set or not in the number. I will be simply incrementing the number count of set bits here. And if the count, I mean that if the set bits are even, then you will definitely know that the result should be 0. When we are having even numbers of ones in the XOR, the result is 0. But if you remove any of the one, so you will get the result as positive result, right? Let's say I will be having this case, right? So if you remove any of the one, you will get positive result here. This is how, if I will be having odd number of ones, this is the, I will take entire thing. So this could be contributing the positive result here. So I will be taking n as my length of the subsequence. If it is not in positive, if it is not having an even number of ones, then I will be taking n minus 1, because I will be removing one of the one number which is having bit 1, right? So that could be any number. Yeah. Else I will be taking my answer as n. This is how we can simply do this one. So what, why I maintaining this flag here? So you can see that in the worst case there could be a case that all the elements are 0, right? In the worst case, you can see that the number could be 0 here. Yeah. um, so it could be 0 here. So in this case, initially I will be initializing count 0. So if I could do the, this is an even number, so if I store into my answer, it would be contributing as n minus 1. But this is not the true, this is not the true answer here. So the answer is that in this case you should definitely have 0 here, because you can see that we don't want to update in this, in these cases, right? So and you can break here only. I'm returning 0. So if I am having all the numbers are 0, then I will be simply returning the 0 here. So in other cases I will be having two possibilities. One is even number of ones, the next one is odd number of ones, right? Yeah. If you could see the time complexity of this problem, so for each bit we'll be having 30 bits, and for the, and the inner loop is going from 0 to n, right? That would be n. So this is the time complexity. So the space complexity would be big of 1, right? Yeah, this is all about this second problem. Let's discuss the question number 3 here. So let's read out the question once. You are given a string s consisting of the opening and closing brackets and integer k. A string is k balanced if it is exactly k consecutive openings and if it has exactly k consecutive closings. For example, if k is equal to 3, this is a balanced k balanced string, right? You must repeatedly remove all the non-overlapping k balanced substring from S and then join the remaining parts. Continue this process until no balance k balanced substring exists. Return the final answer. Yeah. Let's discuss the question once in detail. So this is the third question, right? So this is a complete implementation based question. So initially we will be given character of string that would be having like only having like opening brackets and closing brackets. So when we could say this is an balanced substring when we are having um, opening brackets and consecutive closing brackets with respect to these brackets. So the opening closing brackets should be have immediately after the opening brackets. Then only we can consider this should be a valid string here. So when k is equal to 1, so in this case this is an valid balanced substring. When k is equal to 2, so this is an valid balanced string, right? When k is equal to 3, so this is an valid balanced string. So let's take the first test case here. So when k is equal to 3, this is what let me take the first test case is look like something, right? So the k is given 1, so I just want to remove the string k balanced substring, right? K balanced k is equal to 1 means so it should definitely have one closing and one opening immediately. That means after a closing it should definitely have an immediate opening here. So this is what we can call this k is equal to 1 case. Yeah, k balanced substring. So then I should definitely remove this one. So this is the first operation which I can do. So in the next operation I found that there is again an opening and there is one again immediate closing here. So again I will remove this one. Answer for this is empty string. Let's take some other example. So when we are having implementation questions, try to write more test cases, try run the more test cases as much as you can, so that the implementation part doesn't make more hard, right? Yeah. The second question is, let me refresh it. Yeah, I got this one. Okay. Let's take the second test case. This is the second test case. K is equal to 1, right? Um, so the string is like look like something. Yeah, this is a string which is given, and K is equal to 1. So if you can see that, so you found there is one substring that is K balanced, that is having one opening, one closing. This is we should definitely remove this one, and at the resultant string look like something this one, right? So this is not a k balance because we don't find any immediate closing after the opening here. So this is the second test case. Just move to the next test case here. This would be make more give more idea here. So this test case provide more idea. Yeah. There is a three balanced substring. Just I want to remove this one. So the third test cases look something like this one. Sorry, not this one. And k is equal to 3. You can see that these are three openings. You found three closings immediately, right? So this satisfied this one, is satisfied this one get cancelled, and you are left with this one because there is no other substring which is having k balanced substring, right? Yeah, let's observe the how we can solve this problem. So if you can think like let's write something like, yeah, this is a string given. So when k is equal to 1, you are looking for the 2 into k size substring, right? Let's take k is equal to, when you took the k is equal to 1 here. So this is what actually we want to check this is an balanced or not, right? So this is the main goal of our of this question. And when we are having k is equal to, so main goal is to check this 2 into k, that means 4 size substring, that is balanced or not. When you found k is equal to 3, you can see that 2 into k is 6 size substring, is it balanced or not? So let's simulate this test case here. So yeah, when I'm standing here, I will put into my answer. Again I will be going, when until I will found opening, I will be go on putting into my answer here. I found again opening. So when you encounter an opening, closing here, so again you will put this one, again put this one. So when we actually having an in this case I will be taking k is equal to 2 right here. So let me erase it out. So let me write it clearly. So I will be having k is equal to 2 for this test case here. So k is equal to 2 means I should definitely have an balanced substring. That should be 2 into 2, 4 size, at least 4 size. Then only I would say that this is a balanced substring. Otherwise, if it is not 4 size, then it's not a balanced substring. It's not satisfying this, right? It should be greater than or equal to the 4, at least 4. So I just want to push all these brackets into my result string until I will not found any substring that is size 4. I will be here. I will putting this one 2 size. I will putting this one 3 size. I will putting this one. When I'm putting this closing bracket into my result, when I'm putting this into my this, I will be calling this as result. So I immediately found that this is a 4 size substring. I just want to check that is it an possible to, is it an balanced or not, right? I just want to check that is it unbalanced or not. So you can see that this is not a balanced substring. So we will see how we can check this. So this is a main thing we actually want to think more about this one, how we can check this one. So it's very easy to traverse and put find the k size substring, but the main goal is to find is it to check the is it balanced or not, right? Yeah. Let's move to the, and we can simply see that this is not a balanced here, and we will go and put this again you can see this now the size is greater than or equal to k. Then again I need to check that this is balanced or not, right? So when k is equal to 2, I told that we just want to focus on the k is equal to 4 size substring. So this is actually want to focus on and just want to check that is it balanced or not, right? If it is, you can see this is unbalanced, we can simply erase this one from our result, and our result is only remains with the this opening. And you can see that this will get cancelled, this will get cancelled, this will get cancelled, and we are at here, and I will be pushing into my answer. I will be pushing, this is not a size greater than equal to k, again pushing into my, sorry, this should be closing here, this should be closing here, again this should be closing here. I found that this is a 4 size substring. Again I just want to check that this is balanced or not, right? If it is balanced or not, what you can do is that yeah, it's very clear that we can see that it's a balanced substring. I just want to remove from my result, my result is empty now, and you can see this is got cancelled. So they are we found these are the balanced substrings, right? um, I I think you might have question that yeah, we got that one. I think we left with this one, right? Because we haven't found any closing for this one. So we just found for this group, and this is a balanced group. Let's move to this next one. I will be putting into my answer. I will be putting into my answer. So you can see that we don't found any 4 size substring to check this is balanced or not. So this is our final answer. So the main goal is to the first idea is to find for each index, for each index, check For each index, check um, substring substring greater than or equal to k. Then check the substring. Check check the substring is balanced or not. If it isn't balanced, then it's okay. If it is not balanced, we just want to remove that from the our result. Is balanced or not, right? So these are the two points we actually want to implement in this question. Let's see how we can actually want see this is the string is balanced. Let's say I will be having k is equal to 2, right? I will be having k is equal to 2. The string is look like something this one. Okay. um so I just want to traverse from the, so that if you can see length of the string is 4, that is I just want to length is 2 into k, that is 4 length. And I just want to traverse from I is equal to 0 to k. And let's see how we can traverse here. So there is two parts. First part is opening, second part is closing, right? So if it, the resultant strings is definitely an even number, so we can definitely say that we can divide this substring into two parts in equal parts. And we'll simply go and check. First part should be definitely have all the openings, and the second part should be definitely have all the closing. Let's see how we can do this one. So the first index I will be first part here. I will be writing first part here, and I will be writing second part. How we can second part? Let's say how we can find this is an starting index here. If you can take the total length of the string, that is 4 here, 4 minus 2 into k plus, and you are traversing from I is equal to 0 to I is equal to 1, because k is equal to 2 here. So you are simply traversing from I is equal to 0 to k here, k minus 1. Okay. Initially it would be 0 here. I is equal when I is equal to 0, the starting point is 0 here. You got this point, right? So I want to reach this point 0, 1, 2, 3. If I want this point, how I can do this one? It's simple. 4 minus k plus 4 minus k means you are simply jumping to the k steps ahead, right? That is 2, right? 2 k 4 minus k plus that is I 0 here. So you can see that the result should be 2 here, right? So this is the starting index of the second part, is starting index of this first part. And you can go on traverse like it's an I is equal to 1. You can do I is equal to 0. It's an I is equal to 0. You can go I is equal to 1. You are simply moving the one index ahead, right? Right, this is how we can see this is a balance. For each index in the first part, you should only have the you should only have openings. In the second part, only have in the second part we should only have closings, right here. So this is what actually the condition is. um I think it's more clear if you can see the code once. You can see the code. Yeah, it's bit harder to imagine this one. I will be explaining again this one. I will be maintaining one string result, right? Sorry, I took the two strings here. I just want to remove this one. Yeah, I will be traversing from the all the characters, right? I will be gone putting the each character, I mean that each bracket into my result. When I found there is a valid substring which is having 2 into k size, means that is a valid substring. We actually want to check this is an balanced or not. So for I will be keeping one flag that could be reminding me that is an balanced or not. If it isn't balanced, we can simply put resize our we just want to remove that from our answer, right? So let's see. So I will be going for all the um I mean that all the indices from first part and second part. This is an for the first part, and this is this one for the second part. And you can see that So if this is the second first part, if I found any of these not equal to opening, that means if I found any closing here, not equal to opening means there should be closing here. So if I found any closing in the first part, that's it's an invalid, right? I will be simply make my flagging, I will be initializing my flag as false, and I will be breaking this, and I will be moving out from here. If it is in the second part, I should definitely have all the closing, right? If it is not in closing, I should have definitely one any of the opening. So I will be simply making my flag as false, and I will be breaking this condition, and I will be updating my answer here. So if I found flag as true, that means I found an balanced substring of k balanced substring, right? Then I will simply removing this from my result is from my result. So this is how we can remove this one. So there is an initial n size, let's say n size. If I found 2 into k size substring has balance, and I am simply removing that one. So the removal will be happened at the last only, right? This is always an case we observed in the previous test case here. These two are the things which you actually need to dry run 2 to 3 examples, then you will get more idea on this one. This is how we can get in the first part, this is how we can get in the second part, and go and check is it valid or not. If you can think the time complexity here, I would say the time complexity in the worst case is not approx completely like big of n into k. So it's less than big of n into k, right? Because in a lot of cases you can see that we are keeping breaking this complete loop here, right? That means if you found any of the invalid case, then we are completely breaking this case. So if you found any valid case, then we'll simply removing this from the answer here. Yeah, this is all about this question here. Thank you for watching.